Hello, hello, hello. Welcome to the Things Logistics webinar. I hope everybody can hear me. I'm Ben. I'm a technical content creator here at the Things Industries. And today we're streaming live on lots of platforms. We're on Facebook, we're on YouTube, we're on LinkedIn. It looks like we have about 30 people online now. And at the end, we'll do Q&A. So if you have any questions, please post them in the chat on whatever platform you're on, and we'll try to get to them during the course of the webinar. We also have some nice guests today. And so if you have any questions for them, also stick them in the chat, and we'll try to do some live Q&A along the way. It's always fun. I'll pull up the agenda here. So today, we'll first cover LoRaWAN and logistics in 5 minutes. I prepared a little bit of video about why logistics and IoT are so difficult and how LoRaWAN can address some of those challenges. Then we'll talk quickly about the Things conference. We've got a lot of exciting announcements. And then we have interviews with Semtech, IRNAS, and Blues Wireless. And then, of course, we have Q&A. So drop your questions in the chat. So first, I will play a little 5-minute video here about logistics and LoRaWAN. Here we go. To LoRaWAN and logistics in 5 minutes. Today, we'll explore what logistics really is, and we'll talk about why logistics and IoT are so difficult together. Then, we'll talk about LoRaWAN and why it's uniquely suited to address a lot of these challenges. Let's get started. So, today on the agenda. First, I'll explain what we mean by logistics. Then, I'll address some particularities of this vertical, which make it difficult to do IoT at scale. I'll talk about why LoRaWAN is able to address these challenges. Finally, we'll look at the Lorawan ecosystem and look at some of the logistics use cases LoRaWAN is already addressing. So, what is logistics? When we talk about logistics, we're talking about moving goods, using multiple methods of transportation, and with multiple points of aggregation where these goods need to be tracked. This could mean sending a package to someone in your own city via courier or via plane to another continent. Logistics includes local, air, last mile, and all other kinds of goods transit and tracking. So why is the Internet of Things so difficult in logistics? Well, first of all, it's hard to guarantee that there will be some kind of network coverage everywhere goods go. Goods might cross borders, go to remote areas, or be inside where buildings block network access. Next, location determination is actually really difficult. When you pull out your iPhone and it instantly tells you where you are, there's a lot of complex, energy-intensive stuff going on in the background. Getting a GPS fix is battery-intensive and slow. Integrating IoT data into a company's ERP system can be a major challenge. We find that data is only really useful when it's actually integrated into business processes, where it triggers automatic actions and saves people time and energy. Data in some random dashboard doesn't really drive change. Security and privacy are obvious concerns with network-connected goods. Finally, systems that run without hiccups are hard to design. Incrementally developed IoT deployments tend to be less error-prone than big bang developments, so the ability to marginally increase coverage and tracking is important. Why LoRaWAN and logistics then? Well, here's one of my favorite slides about why LoRaWAN is awesome. 6 of these points directly address the challenges we just saw. LoRaWAN is long range and operates in the license-free spectrum, so you can build your own coverage absolutely anywhere you need it. Deep indoor penetration also allows LoRaWAN devices to work in fridges, shipping containers, and deep inside buildings. LoRaWAN is end-to-end secured by design, using modern AES encryption. Finally, the LoRaWAN ecosystem means there's a device for every use case. Using the Things stack, our LoRaWAN network server, it's really simple to build redundant networks which easily integrate with any ERP system and actually impact business processes. So, about the LoRaWAN ecosystem. In the LoRaWAN device repository, there are thousands of devices which you can sort and search by sensor type. One of the most innovative LoRaWAN chips is the LR1110, which allows passive GPS and Wi-Fi scanning with incredibly low power use by leaving difficult GPS resolution to be done in the cloud. LR1110 devices can provide on-the-hour GPS fixes for years on a single battery. Let's quickly look at some LoRaWAN use cases. Tadelos is using LoRaWAN weight sensors to track inventory inside warehouses. Farox is doing intelligent indoor tracking inside warehouses with LoRaWAN sensors. Halter tracks the location and health of cattle and saves farmers thousands of hours by automating cattle herding. And Wilhelmsen builds LoRaWAN networks on ships to track inventory wherever in the world their ships are. So what can LoRaWAN do for you? Follow the link in the description below if you want us to help building your LoRaWAN solution. And as a last note, if you're interested in learning more about LoRaWAN, join us for the biggest conference on LoRaWAN, the Things Conference in Amsterdam in September. Thanks for watching. Welcome back. So that was 5 minutes on LoRaWAN and logistics, why it's difficult, and why LoRaWAN is kind of uniquely suited to deal with a lot of the problems of IoT in logistics. You're watching the Things Logistic webinar for anybody who's just joining. We're focusing today on logistics and IoT, why it's difficult. And as I mentioned at the end of that little 5-minute video, we have the Things Conference coming up. So this webinar is part of a series of online webinars that we do all year about LoRaWAN leading up to the Things Conference in September. And we just made a big announcement. At the Things Conference this year, we're going to do the world's biggest digital twin. So we're going to turn the whole building smart. We're collaborating with a bunch of sensor developers. And so for the conference, you'll be able to put on AR goggles if you're at the conference and not navigate the actual building and then see sensor overlays in augmented reality. And even if you're not actually there, you'll also be able to monitor the venue live. And so you can see things like air quality, booth and stage occupancy, and lots of other like sensor partner data. So the Things Conference is the largest LoRaWAN conference in the world, and it's the best place to meet builders and buyers from the LoRaWAN ecosystem. So save it in your calendars. That's the 22nd and 23rd of September. And Vinke made a really exciting Things Conference digital twin announcement video, and he asked me to play it for everybody, just in case anybody missed it. So if you want to see what the venue looks like and kind of learn a little bit about this world's biggest digital twin, I'm going to show you right now what that's going to look like. 3, 2, 1, here we go.
Welcome to the venue of the Things Conference 2022, 22nd and 23rd of September here in Amsterdam. We're gonna again have a physical conference with all the players in the LoRaWAN ecosystem. You will meet everybody, you will find all the devices out there, you can touch them, you can play with them, you can speak to the vendors, all here in this place. And we're gonna do one extra special thing. We're gonna build the world's largest digital twin with hundreds of different LoRaWAN sensors, and we're gonna put them all in this building, and you will be able to play and look at them both here physically at the conference, but also in the virtual digital twin. I want to invite you to this conference again this year, and I hope to see you there.
So there you saw a little bit of the venue for the Things Conference, in September. We're really excited to be back in person after a few years of virtual events. So that's really exciting. If you want to catch up with any of these videos, everything is on our YouTube. So if you go to the YouTube Things Network, and we also have the thingsnetwork.org/learn, where all of the information that we can cover in these webinars is available for you to learn at any time. So that's the thingsnetwork.org/learn. And then our YouTube is the Things Network. Today, in this webinar, we are focusing on logistics. And like I said in the video, logistics for us means moving goods across multiple modes with multiple points of aggregation where goods need to be tracked. And logistics is really difficult for IoT because coverage is not always available. Security is a big issue. Battery-powered devices can have energy restrictions. And then, of course, the cost of expanding your own network, if the coverage is not there, can be prohibitive. And we think that LoRaWAN is uniquely suited to deal with a lot of these challenges. And so today we have a lot of exciting guests here to talk about what the future holds for LoRaWAN and logistics. So up first, we have Carlo Tinella, who is the Senior Product Marketing Manager at Semtech. And Carlo has been working with semiconductors for more than 2 years. And he's fascinated by the potential of LoRa to contribute for a better, safer, and more sustainable world. I see Carlo in the backstage there, so I'm going to bring him on. And for anybody watching online, I have the chat here live. And so if you have any questions, please drop them in the chat and we'll try to answer them. Carlo, I'm going to bring you on. Here we go. Hi, Carlo.
Hello. Good day, everyone. So again, thanks for inviting me to this event, and I'm very glad to share my small knowledge about our products portfolio and how we can really bring our technology and serving for a better world, I would say.
Yeah, thanks a lot for taking the time to be here. I have some questions prepared for you. So if you're ready, we'll get to them. And the first thing I want to ask is, what kind of use cases are actually out there now for LoRaWAN and logistics?
Okay, of course we are seeing a predominance of use cases where the traveling god is a high value asset, or sometimes it's a perishable asset actually. So cold chain monitoring for food or pharmaceutical products are the golden use cases, I would say. As a concrete example, a few days ago, Semtech issued a press release with a customer called YTrack about the deployment of their track and trace solution for a maritime vector that transports food and medicine between Spain and Canarias Islands. That's one of the main use cases we are seeing rising. But we are also seeing the emergence of use cases where there is a need to track fleets of general purpose containers, containers that can serve operations in specific industries and activities. So here, the goal is to track not what is the content, but really the container itself. That sometimes can travel across multiple sites. These may be air cargo containers, racks transporting manufactured pieces that must be assembled elsewhere, cylinders transporting gases, train wagons. Very often, the customer wants to start from the most simple case of check-in and check-out, where there is a need to know when one of those objects enters or gets out from a site. And once they start testing or realizing the value offered by the greater visibility on these fleets, so they decide to move forward, extending the tracking over other steps of the journey, or even sometimes adding more sensing information, really enriching the information they can get beyond the position itself. So really conditional monitoring of what is the container or what is the content in sometimes. Okay, so those are the two main use cases where we are seeing with a different approach actually.
I see. And another question that I have here is about 2.4 gigahertz. Does that bring something exciting for LoRaWAN?
Absolutely. We have to admit that, as you said, by the way, inserting track and trace into logistics flows is a very complex task. And where there is a need to deal with assets that can move across continents, different regions, the possibility to operate in a band that may ensure uniformity, the same behavior, the same system that works in the same way wherever you are in the world, this really greatly simplifies such tasks. So really, that's what LoRa to the 4 GHz brings, and that's why we, a few years ago, we at Semtech decided to add this feature into our portfolio. And recently, we also enriched our offering, our LoRa Edge platform, which is dedicated to offer LoRa connectivity with a very low power cloud-based geolocation. So we enriched this LoRa Edge family with a new device that is capable to offer this very low power geolocation with operating LoRa into two bands, the sub-gigahertz and to the 4 gigahertz band. So really high, we can now address a broader spectra of use cases with much higher flexibility offered to the market and our customers.
And you're talking about the LR1110 there?
I'm talking about LR1120, so the brother of LR1110. Yeah.
Okay.
Thanks.
And so 2.4 gigahertz is a LoRaWAN spectrum that is that is permitted to be used all over the world, correct?
Correct. So we made a proposal for a protocol that emulates LoRaWAN to some extent, and this allows the same operation, the same frequency plan, same conditions, operational conditions, wherever you are. You can be in US, in Europe, or China, and the system will work in the same way. So we are really speaking about a single SKU. Okay, of course, customer must accept that at 2 to 4 gigahertz for the same amount of transmitted power, the range is going to be lower than what you can get at sub gigahertz. But it's really a matter of addressing different use cases where the customer can stand with a few hundred of meters of coverage instead of reaching kilometers. So really for local networks or even mobile networks, like for instance, can be a boat that travels across seas and oceans. This is a very good choice.
Got it. Yeah, I think Wilhelmsen is one of our partners who is doing 2.4 gigahertz on ships. Do you have any examples of other use cases maybe that are real killers for 2.4 gigahertz?
White track. So I mentioned this customer at the beginning. So they actually have a solution that can work in both bands. Okay, and we are seeing others, but not yet public, I would say.
Okay.
But they are coming. They are coming.
Okay. And so your colleague Randy, I think couldn't make it today, but I have some more questions that were supposed to be for him. Do you want me to? Do you want to talk about those as well?
Go ahead.
So with Randy, I wanted to talk about how the challenges in the logistic industry are spurring innovation. So especially supply chain and logistics. What do you have to say to that?
For sure. I mean, what is really spurring innovation is the awareness that IoT can bring higher visibility in all the supply chain and the logistic flows. Okay, so it's really the target is to get this high visibility across all the process, and high visibility as a twofold impact, positive impact. One on the operational side, and another one on the end user. Okay, really the end of the value chain. So on the operational side, it gives an improved efficiencies and consequently a much higher sustainability of the process. Okay, we can use resources more efficiently. And for instance, let's think about a shipper that gets an alarm saying that an accident has damaged a good or item that is still traveling. Okay, then we can take corrective action of sending the replacement of the good without waiting the arrival of the items at destination, and then realize later that something went wrong. Okay, so this really reduces the time of supply breakdown for the receiving part. Okay, and allows them to plan better their operational task. On the end of the value chain, we can enjoy higher transparency. So visibility translates really in a higher transparencies, and everyone knows that for end users, transparency is becoming a high value service. So increased transparency will always make easier to sell a product. Personally, when I'm waiting for a shipping at home, I greatly appreciate the possibility to track and know when this is what I'm waiting is gonna arrive. So I could plan my agenda and stay at home at the right time, or even I can plan the other tasks that are related to the item that I'm gonna receive. So really, greater visibility with an impact on the operational efficiencies and also the transparency that is becoming very, very important for the end user. Can be a consumer, but not only a consumer.
Yeah, I was thinking the same thing about the package delivery. I think that's something that we can all relate to. The more you know about when your deliveries are going to come, the easier your life is. Yeah,
Absolutely.
and it made me think about this other point that we're really trying to drive now at TTI, which is that all of this additional collection of data is really, really valuable when it starts to actually directly impact business processes. So I know, for example, that with some shipping services now, I get an email saying, okay, we're probably going to arrive between this time and this time. Sometimes I have a link where I can actually follow the delivery truck, for example. So I have a really, really good idea when my package is going to come. And that just allows me to plan my life with more efficiency. And so turning these data points into really consumable and business transforming data, I think, is the future of IoT in this way.
It's the future. It's the way to go. I really liked your one of your initial statement in the video that you just played, when you said, I mean, data in a random table, Excel table, means nothing actually.
Yeah.
We have to take this data and make them capable to action, to produce actions actually.
Yeah, and we can do that both on the supplier side and on the consumer side.
Perfect.
Yeah. Another question. So how can LPWAN technologies help unify the world's ability to ship, store, and trade goods?
That's, I mean, we are in the first age of the LP1 for sure. Now, in my opinion, is a technology that is going to revolutionize this field, because can provide a very affordable mean to get this intelligence out from the process. Okay, and once this intelligence is out, then it's a matter of digesting it in the right way, as you okay.
Hello.
So it's digest it in the right way in those platforms that are now creating this distributed intelligence in the cloud. So really, we are in the first step. That's the funny part of our day-to-day operations. We are really living a revolution in the way logistic is transforming itself, and in the way it also become an economical player, really, with a much better efficiency in the usage of the resources, much precise, I would say, focus on the economical impact that the logistic industry has on our lives. So it's exciting, and I think the most of the I'll say the positive impacts are still to come.
Yeah, I like the way you put that. We're living in a revolution, and I think we really also depend very heavily on the actions of the developer community, for example, to really be evangelists for a lot of this this new technology. And it looks like we have a question in the chat that's kind of related to that. So somebody asked if we can direct him to starting for developing with Lorawan. And I would say that the best resource, if I may say so myself, is the thingsnetwork.org/learn. There you can follow a lot of our guides about getting started with Lorawan, and then there's also a certification. So once you've consumed and learned a lot about Lorawan, you can take a test and demonstrate your knowledge there. And Johan has a really, really amazing 1 hour everything you need to know about Lorawan. I can put a link to the thingsnetwork.org/learn there.
Yeah, if I may add, we also have at Semtech, my colleagues enrich continuously our developer portal site with very valuable content, and so I also suggest to have a look at it. You could find very good material and guidance on the way you can start developing.
Yeah. So at the Things Network, at Semtech's developer portal, and at the LoRa Alliance, Yusuf, I would say those are great places to learn more about Lorawan. Let's see. It looks like we don't have any more questions for you now, Carlo. So thank you so much for being here
You're welcome.
and for your really valuable answers. And I''ll see you again soon. I think we'll see you in September in
I
person
hope
at the
so.
Things Conference.
Thanks so much.
Yeah. Thanks,
Bye
Carlo.
bye.
Ciao. All right, so that was Carlo Tinella. Carlo is the Senior Product Marketing Manager at Semtech, where he works with a lot of Lorawan and has a pretty cool and unique insight into where the technology is going. Like we mentioned, if you want to learn more about Lorawan, please head over to thethingsnetwork.org/learn, where we have lots of educational information. And also, Carlo and I are both going to be at the Things Conference in September, where lots of people from the Lorawan ecosystem will meet up to talk about all interesting things Lorawan. So there's a link there. If you go to thethingsconference.com, you can learn more, and hopefully we see you there in September. Right now in the logistics webinar, we have more interviews coming up, and we appreciate your questions in the chat. So next up, I'm going to call on Brandon from Blues Wireless. Brandon is the Vice President of Developer Experience, and he is a lover of IoT. He's a lover of the web, mobile, and an avid tinkerer. Brandon loves to talk about sensors and circuits, microcontrollers, open source, robots, and whatever new shiny tool or technology has distracted him from that other thing that he was working on. So Brandon, I'm going to bring you in. Here we go. Welcome.
Hey, Ben. Hey, how are you?
And let me get your badge here so everybody knows who you are. Hello. How are you doing?
Hey.
Where are you joining us from today?
I'm in Copenhagen, Denmark right now for a conference. Headed back home tomorrow. So.
Okay. Where's home?
Yeah. Austin, Texas.
Wow. Okay.
Yeah.
Cool. So I have some questions for you today.
Great.
The first thing I want to ask you is what the future holds, in your opinion, for how we move goods with LoRaWAN.
I think the future, and one of the ways that LoRaWAN is really exciting in this space, is this concept of perishables and being able to track perishables. I like to say that perishable devices need fungible trackers. We need to get to this place where if the cost of the thing that you're shipping around the world is such that you can't afford to put a cellular or a Wi-Fi radio in every single box or every single pallet, you need a fungible approach. You need something where you can actually build low-cost sensors and attach those to pallets or to boxes or even to individual product, and then rely on your gateway technologies, on LoRaWAN in particular, to be able to give you that backhaul, that connectivity to the cloud for the purpose of tracking. And then the beauty of that approach is that when you get into a place, this is especially true in shipping and tracking of fungible goods, but when a ship starts in Shanghai and then lands in the port of San Francisco, and the individual pallets in the shipping container then go their separate ways on trains and trucks and whatnot, you still have those same low-cost sensors, but they're connecting to different towers, or they're connecting to different gateways. They're connecting to different hardware that then still gets their data back to the right place, but those devices can then spider all over the world, and ultimately their data gets where they need to go. So you get that level of fidelity, like you were just talking about, with getting sort of accurate shipping times, or actually accurate delivery times and things like that. And I really think that with the technologies that we're seeing in this space, that we're getting to that point where the low-cost sensors allow us to be able to really consider adding sensors and adding devices at a smaller scale than we did previously, because it just wasn't cost efficient.
Got it. Yeah. So the unique low cost of devices, and then also the ability to expand your own coverage with relatively inexpensive hardware. Cool. And what are you guys working on at Blues to drive sort of LoRaWAN and logistics?
So we are actually working on a product that we will have. It's in beta right now, and it'll be available for our customer base in August, and we'll have it with us at the Things Conference in September. I'm really excited to be there in person, but it's a product called Sparrow, and it is basically a set of LoRa devices that we've built that are based on an STM32 LoRa SIP. And they give you it is very similar to a lot of other just end nodes out there, but wanting to give developers an easy way to get started, and it's purpose built to work with our our note card product for cellular backhaul on the gateway side and things like that. And so it's exciting. It's a product that we're sort of building a developer preview or a developer kit around right now. And once we get that in the hands of developers, we'll see where it goes. But as we've had early customers that look at it, there's definitely a lot of interest that we've seen from agricultural customers that are in broad installations. But we have a couple of customers that are in the shipping space, that are in logistics, and as they've worked with our traditional devices, they really saw a need for getting something more on that fungible sensor, fungible tracker side with LoRa and with LoRaWAN. So we're excited to get that in their hands as well.
I see. What's the USP then of the card?
What's that?
What's the USP? Can you explain a little bit more about what's unique about the note card system and your
yeah, absolutely. So our note card module is a cellular IoT device, and it's meant to sort of be the backhaul piece to the solution. And so this is a device that we've had in market since January of 2020, and its sort of core value proposition is it's meant to be a developer-friendly sort of single-cost cellular IoT device. So the cost of the device comes with 10 years of cellular data, 10 years of access, and 500 megs of cellular data included in the cost of the device. So whereas there are other devices on the market where there's sort of a mini data plan that comes along with the device, you sort of get that data included. The price is on the tin. And you have an opportunity to get started with something right away. And so the other piece of that that's really interesting is that the programming model for those devices is JSON. So any developer in any programming language with any board can actually send data to the device. And so we think this pairs really well with the Sparrow LoRa system we were talking about, because effectively the communication mechanism allows developers to very quickly add sensor applications on these low-cost devices, and then write firmware that can very quickly talk to the gateway and then get that data backhauled into the cloud for processing and additional work. So we're excited to bring those areas more closely together. I mean, we're big believers that many IoT solutions are really require some combination of LPWAN technologies that we're looking a lot of times at LoRa plus cellular or LoRa plus Ethernet. We're talking about, Bluetooth and mesh-based systems and things like that. And in most solutions, I think there's almost a menu of choices, and the more developers have options where they can actually get connectivity where they need it, at the edge or in a field or in a remote area, then we're really excited to help facilitate that where we can.
Cool. So the note card is kind of a gateway and backhaul and data all in one, and then the Sparrow is a developer kit for
as a developer kit with LoRa, with LoRa modules for then talking to that ecosystem.
Got it. Okay.
Yeah.
Let's see. We have a few questions in the chat here. I don't know if you're a LoRaWAN 2.4 gigahertz expert.
I'm not. Okay. If you ask me that question, I'll be Googling curiously or just saying I don't know.
Okay, let's see. We'll let that one go. Somebody asked about flying cargo using LoRaWAN, and I think that he is correct that we would need to use 2.4 gigahertz in order to do that and meet the regional parameters in all of the areas that it might fly. So a loose yes. Let's see, what else? Okay. Okay, so the LoRa Edge is a great innovation regarding tracker batteries consumption. What is the development like of LoRaWAN and modules, especially in logistics? Do you have an idea?
Yeah, I do. So this is interesting because obviously power in your data rate is very much at a premium. Many of these devices, even in those fungible devices, need to run on battery power for as long as they possibly can, whether it's across the sea or for the entire time that they're in the supply chain. And I think that many of the trackers in this space, I mean, they're off-the-shelf trackers, and we work with customers that are looking at off-the-shelf trackers, but we work with a lot of customers that are looking at sort of building their own end solutions. And this is a case where I feel like the more you can start with a kit or a module or something like like a simple node device for a developer kit, you have then that ability to tune the application based on your need, and so you could get sort of that right, that right sweet spot of sort of power versus your data link versus how often you're transmitting and things like that. So I think it's in the eye of the beholder largely, but I recommend finding dev kits if you think you're going to need to customize, because a lot of finished solutions don't give you that same level of developer friendly customization.
Yeah, and there's, I guess the less you can reinvent the wheel, the better.
Absolutely.
So, we were kind of thinking the same thing with the generic node, where you have some basic stuff on there, and then you can kind of tune the application, and that gives you a head start for then if you do need to develop a custom device doing it. And I know Luca, who we'll have on next, he last time he talked, he gave a little a short presentation about what you should think about if you want to develop your own device, and the answer was basically just don't develop your own device. If there's any way that you can buy something off the shelf that will do the trick, try to do that. And then there's some decision charts that you can go through, and maybe you will end up developing your own device. But getting started, getting traction at the beginning is really closely connected to having off-the-shelf parts that you can use.
Yeah, I would definitely agree in the sense that I'd not ever recommend starting with a module and going up from there. So you can find a kit. The generic node's a great example. Find a kit that gives you a starting point you can tune and go. And if you know your use case is locked, if you feel good about how your use case is defined, there are a lot of great, full-on trackers and nodes you can buy that have everything there for you. Yeah.
And LoRaWAN is a pretty complex protocol. So designing something from scratch, which means that is going to eat up a lot of your R&D.
Absolutely.
Yeah. Well, it looks like that's all the questions that we have for now, Brandon. Thank you so much for your time. It's really, really great to catch up with you. And I hope we'll see you in September in Amsterdam.
Definitely will. Thanks, Ben. Talk to you soon.
Thanks, Brandon. See you. All right. So that was Brandon from Blues Wireless. Brandon is the VP of Developer Experience. And Blues makes a lot of really cool products that basically make it easy for you to jumpstart your IoT solution building. Next up, we have Luca. Luca works at IRNAS. He's actually the founder and the head of development there. So he leads the institute, IRNAS, and his multidisciplinary team develops systems for the future, ranging from specialized IoT devices to open medical devices and 3D bioprinting. Luca is basically he's seen more LoRaWAN devices than anybody I know, and he always has some really cool insight. So, Luca, we're going to bring you on here. Welcome.
Hello, everyone.
Nice
to be back with you.
There is your badge. How are you doing?
So, I hear very interesting topics today about the logistics, and that's definitely an exciting sector, because when things go wrong in logistics, the costs are quite immense there. So doing things right from the get-go is pretty much the priority for everyone involved. And from that perspective, technology really helps us a lot. So as you guys have heard from Blues Wireless, they're doing a really cool set of things to get you started. So I would cover today a bit about the technology and the new things that are being unlocked right now. You've heard things from Semtech, what's possible. We're usually the ones that are using this in practice and implementing this for our clients. So I can share some best practices and what we've seen, for example, works very well in this kinds of applications. To get your imagination started, a LoRaWAN device with all antennas included, everything can be of this size even if you wanted to. So essentially you can make it of a coin battery cell size, fits very well within your palm or within your hand. So you can do something like this, you can do something like this, you can do something like this, or something like this. So all the sizes are possible.
Are those all trackers?
Sorry?
Are those all trackers?
Those are all trackers for various types of applications. The interesting part about all of the tracker options is we very rarely build something that uses only one communication technology. So where you really win with these types of solutions is where you have one or two or multiple things working in tandem, which allow you to do a lot of very practical things. So as you've heard, LR1110 is a great device from Semtech, which joins not only LoRa 868.915, but also Wi-Fi positioning, low power GPS positioning, and now the new version LR1120, which just came out, does also LoRa 2.4 gigahertz. So in a very small chip, you can get a lot of functionality in. And now the question comes, how do you actually combine those in a sensible manner? So what we do very often with these tracking devices is, firstly, you want them to distinguish between being indoor and outdoor. Because particularly if you can determine you're indoor, you don't necessarily want to go for a GPS fix because you won't get it, pretty much. So that's when you resort to Wi-Fi scanning, to say Bluetooth scanning, you have a Bluetooth radio in place, or other things. If, for example, you have your locations under control, so let's imagine a use case where you're moving things with a truck between depot A and B and C. So like your shipping pallets, your IBC containers, your boxes, whatever that is, pretty much ends up on your own locations. LoRa is a very nice solution for that, because sooner or later the devices show up in a known environment. Tracking in the field with them might be a bit of a trick sometimes. So what we've seen as a good communication practice is, quite often we build devices which have LoRa and NB-IoT within the same device, and then the device switches between the two modes. One gives you lower power, one gives you, no worries about the coverage and about the infrastructure you need to have in place. Now, how to build a good logistics product is really understanding those cases. So making sure if you have a case where your environment is tightly enough controlled, you can conserve a lot of battery, build a lot smaller and cheaper device. The more universal you need to make it to work anywhere in the world, obviously you need to have more communication methods, more options, and that will make it bigger and more expensive.
Can you talk a little bit about some of the devices that you showed and some
Sure.
of the...
So, the things I can show here are pretty much open designs. So here's an interesting one, actually. This one. So this is something we built together with SmartBox as the demonstration of a small device we can build for animal tracking. In logistics, this would be the same as like a pallet tracker or a shipment one. So on a PCB of 30 something millimeters diameter, we can fit actually 2 GPS receivers. So we have a high power GPS receiver which we use for precise positioning upon demand. Send a LoRa message, hey, I need a really precise position, I lost this, get it down to half a meter, really help me locate this. We have the LR1110 low power positioning on it, so which is essentially, hey, every hour tell me roughly where you are, so we can track it in the application. There's Wi-Fi positioning, so hey, it's here indoor, it's in this building or in this street or in this van. And then also we have Bluetooth connectivity on it, which allows us to do user interactions with the device, but at the same time to do really close proximity pairing, sensor talking to a sensor, pairing things together, and so forth. So yeah, really, you can get it this small. The question is the battery. A battery can be small, can be big, really depends on your application. You can do a bit of solar if you have the right use case, and so forth. When you take a step bigger, for example, if you want really updates, say every 15 minutes for a year or so, you go roughly to this size, making a rechargeable unit of sorts, or something like that, which is built for the animal tracking in this case, or pretty much the same electronics built for industrial tracking, putting in a vehicle or on a shipping pallet and so forth. Now, the unlocking part of various technologies working together is actually when you can combine really small units, for example, where you have, say, a set of boxes or a set of pallets, which generally move in large crowds. You can have a few of them equipped with a larger unit that has LoRa or mobile connectivity to the cloud or to your backend, and the rest you put something really low power on them, maybe only LoRa 2.4 gigahertz, and you make devices talk to each other, maybe Bluetooth, and you have devices talk to each other and so forth, which then creates this hybrid use cases, giving you way more options than just sending things through one positioning method. So I know all this may be very abstract, but to boil it down and give you a decision process, you pretty much chart out where your devices are moving through. You decide this is a controlled environment, or this is my environment. This is open world. We don't know what's happening there. You decide what parts of data you need where, and really see where your business added value is, and then select the right technology combination. And usually it's the combination, not a single one, that will give you the benefit in that particular application.
Gotcha. And you mentioned there Bluetooth for devices pairing with each other. What kind of situation would you want to use that in?
So you will use that, for example, where you want to register two devices being in close proximity. You will use that in the case where you want a person through a smartphone or something like that to interact with the shipment. Say, tell the device, okay, you are being shipped now, go to shipping mode. Or here's the extra information, carry that information with you. So when you reach the next point, that's it. Or for someone checking the device status, an example in the shipment space would be you're looking for a shipment maybe that's been damaged. You have a bunch of boxes there. If it's within range, you will connect to it. You will say, make it beep. You'll find it very quickly. While at the same time, through LoRa, your system already knows that someone needs to be out looking for something damaged with like too high G rating, or it's too wet, or there's spillage inside, too warm in the cold chain tracking, and so forth.
Those are really interesting cases. Yeah, thanks for sharing that. And what kind of devices seem like they need? You gave the example of every 15-minute updates versus slower updates. What kind of use cases use one or the other?
So, well, the thinking there is how quick can a human action be related to that shipment? So if you're moving a shipping container, well, it does move that far in an hour, pretty much. So the updates aren't too critical there to have it every minute, because it won't move far. If you're looking at, say, fast delivery services, or say critical medicine, you get to the minutes range where you need to know where it is. Will it be here now, or in right away? But this is kind of the, let's say, old school way of thinking. If you can make your devices smarter to make them recognize events, then you can do event-based messaging. Meaning, say I went up and down a flight of stairs, send a message now. Something is on a truck, it was offloaded from the truck, send the message now when it was offloaded. And then usually it brings a combination with machine learning, with making the device smarter, pretty much of kind of getting the device itself figuring out the environment instead of being just a dumb device sending messages out. And we see quite a bit of future there, because with a good strategy like that, you can save, say, 60-70% of the battery budget you would otherwise need, meaning that you can make it that much smaller or cheaper, and that unlocks quite some scale things.
That's really interesting. So on most of these devices, the most power intensive thing they do is transmit, I guess.
Unless you're doing GPS for high precision positions, so not quick lock, well, not like a quick fix GPS you have from LR1110, then that would be the most powerful. The second one is transmit, but also receive is not to really ignore, because if you have a protocol which constantly talks back and forth, you will have a hard time. For example, one of the common pitfalls we see is people like save delivery, meaning they use a lot of confirmed Lorawan messages. But the caveat there is the probability of message getting lost from device to gateway is much smaller than from the gateway to the device. But if you need to do a whole round trip for a confirmed message, you will be using quite a lot of power there. So in quite some cases, you're much better off maybe just sending the same message twice up to the gateway and not expecting a response, versus the other way around. This really depends on the application again. So good to know your network.
Cool. Yeah, but it sounds like there's a lot of interesting future there in making the devices smarter and then allowing them to do more conditional stuff rather than just transmitting.
Correct, because essentially a stupid device will use as much power as your interval is.
Yeah.
And quite often, you can't make the communication protocol so low power that your device would be viable in that case. So you need to make it smarter.
And what kind of environments are you using to do to put intelligence on these devices? Is that something that you guys are working on at IRNAS?
Yes, so pretty much all environments. What we see, the latest trend is that every device can be smarter. And the fact that the device can be smarter monetizes in two ways. One is lower power, so making it cheaper. But secondly is offering a better insight to the customer, meaning that if your device is only a position sensor or temperature sensor, it can only do that. But as soon as you start the logic of the device sensing the events, you have an inherent added value specific to the application. And that improves your added value to your final customer, which means you can charge more. Or you can have a subscription service on top of that extra knowledge the device has about its environment, and you can build your business model around that. For example, in the cold chain situation, one is send temperature every 15 minutes is great, but if the device can recognize, all right, I had like an atypical temperature change gradient. Hey, like this is the pattern which usually leads to problems. Alert already before you go above the thresholds. So if your threshold is up here, if you see a pattern, you can already be halfway alerting, say, hey, it's not critical yet. Go figure it out before it gets there.
And do you see more of building use case specific, say, models into end devices, or is that something that the manufacturers typically try to provide a generic model that can be, say, adjusted to some parameters and then?
Yeah, so you can't really build a universal model, meaning that if you buy an off-the-shelf device, which is not really specifically solving the niche problem you're trying to solve, it's unlikely that would be in place. So in most cases, you would be the one building that or creating the model. And the future where you can buy IoT devices where you just need to upload models and all the rest is done, it's not there yet, but we're all working towards that. And particularly if you have something like generic node, where you have the basic firmware, you have the device hardware, you can easily create your own solution. And yeah, these are the strategies we often see with many of our clients.
I see. Yeah, I think Edge Impulse has done some cool demos where they've done live learning. I remember Johan doing some push-ups on the stage in order to teach an Arduino, I think, what kind of human actions represent what. To categorize human actions and then just to send one message. So instead of sending all of this data about all of the movements, you can basically just send an integer which says, okay, standing, sitting, with some device intelligence. And
and you can select on which of those events you want to do the sending.
Exactly.
And yeah, what Johan did on stage is a really excellent demonstration, and also it's a demonstration how Edge Impulse makes all this very easy. Is that within minutes, say to an hour, you can build a reasonably functioning model. Obviously, you will spend a few months refining things afterwards for proper field deployment, but you can get something working really quickly, demonstrate it to the field, and create new kinds of added value, which you wouldn't be able to do otherwise, or you need a whole large engineering team for a few months.
Gotcha. Cool. Well, it looks like that wraps up all of our questions. Thank you so much for joining, Mr. Luca.
Thank you very much.
And we will see you in September at the Things Conference, I'm sure.
Indeed. Bye.
Ciao. Okay, so that wraps up our interviews. Thank you, everybody who joined for the Things Logistics webinar today. As a last closing note, if you're interested in LoRaWAN, please join us in September at the Things Conference. You can find tickets and more information at thethingsconference.com. And all of these videos are available afterwards on YouTube. So thanks for everybody who joined. Thanks for all your questions. And you can always catch up afterwards on YouTube. Thanks, everybody. Bye.